All right, good morning, everybody. It is 11/20/20, and it is Monday. I hope you guys are doing well. It's good to see that you're here. Um, Please let me know, as always, as we go through this lesson. If you have any questions, you can use your microphone or you can use the chat to say hello and ask questions. Today, we're going to continue our look at conics. We're going to be going into ellipses. We're going to be spending 2 days on ellipses because looking at the content, it was a little too much to do 1 day with this. So just to give everyone a heads up, please know that the end of this trimester is March 12th. That means we have just over 2 weeks left. Holy moly, 2 weeks left. So what we're going to be doing is we're going to be spending 2 days on ellipses, and then we're going to be spending 2 days on hyperbolas. And then we'll have 1 day of review before your final. So just wanted to make sure you guys knew that and have an idea of what that's going to look like. Okay, so 2 weeks left. We're going to spend 2 days on ellipses, 2 days on hyperbolas, and then we'll have a review day and your final. Okay? All right. Again, if you guys have questions, please let me know. I'd love to help. And let's keep going there. Also, remember that all of my office hours are now in the morning. So make sure you guys join up if you'd like to do that. All right. So let's go ahead. We're taking a look at ellipses day 1. So let's first talk about the definition of an ellipse because it gets a little weird because it turns out that circles are a special ellipse. Okay. So an ellipse, so let's take a look at the definition. Okay. And it's really important that we start out with this definition. Oh my gosh, people joining late is really frustrating. Okay, so it's the set of all points in a plane so it's the set of all the points in the planes which sums of distance between fixed points and these are called foci. So I'm off the thing. So it's the set of all points in a plane which sums of distance between fixed points. This should be points. Foci. So this is called foci. So the set of all points in a plane which the sums of the distance between fixed points, or which are called foci, is constant. Okay. Now it's really important because an ellipse is in a super important shape. Oh my gosh, ellipses are incredibly important. And it turns out a circle is actually a special ellipse. I can't speak. So what we're gonna do is if I had string, and I don't have string, I guess I could have taken apart one of my shoes, but I was too lazy to do that. To make an ellipse, you start with 2 foci. Okay, so you're gonna have foci 1 and focus 1, focus 2. Foci is plural focus, right? So this would be a focus, and this would be a focus, and the plural of focus is foci. And you guys have seen this in math before, right? When a word ends in us, to make it plural, you drop the us and you make it I, right? It's very American, right? It's like one of the most American English things we can add to the language, right? So you drop us and you add I. Okay, so foci is just plural for focus. So what we're doing here is that we're going to create points. And these points, xy, let's make that a comma, xy, this distance here, so if this is d1 and this is d2, then d1 plus d2 will always equal the same constant k. So for example, if I had another point here, so let's say this is x2, y2, then d1 sub 2 and d2 sub 2, so d1 sub 2 plus d2 sub 2 would equal the same constant. Okay, So the sum of the distance from the focus, the foci, to the point is going to be the same. And this creates an ellipse. And you can tell it's just like a smushed circle, a non-perfect circle. Okay. I did really terribly there, didn't I? Okay, and to do this, what you do is you just take a piece of string, you hold the piece of string here, and then you go like this, and here I can go. You just hold the piece of string, and then you put your pencil inside the string and go around like this. And that's how you create an ellipse. Okay? Now, so to get a circle, the foci are on the same point. Okay, so to get a circle, the foci are in the same point. So if focus 1 and focus 2 were in the same point, then, right, the distance is always the same. It's the radius, right? Okay, so that's what an ellipse is. An ellipse is it has two foci. The distance for every point on that circle, or on the ellipse, sorry, is going to be the sum of the distance between focus 1 and focus 2 is going to be the same. Okay, so that's the definition. Does anybody have questions about that? I feel like I didn't do the best job I possibly could of teaching that, but I just want you guys to be aware of what it is. Are you guys okay with what an ellipse is? So it's like a circle, but instead of having focus 1 and focus 2 overlapping, they're separated. Okay? All right. So we need to go ahead and define some stuff. So let's go ahead and define some stuff. So we're going to have, here's an ellipse. We're going to have, and this is the important part. So we're going to have one axis, another one. Okay. So let's go ahead and label some important pieces here. Okay. So this right here is the center. Okay. Once in an ellipse, one axis is going to be bigger than the other. Do you see how the top down is kind of smushed and the left to right is kind of bigger? So the major axis is the bigger axis. Okay, so the major is the bigger part, and then that means this is the minor. Okay, so you have a major axis and you have a minor axis. So the major is with the bloated part. Okay, so we have our center, and then you're going to have your two foci. Right, so foci 1, foci 2. And I label it 1 and 2. You can name them whatever you want. Okay, and then you're going to have some point xy right here. Okay, so it's important to know that. So now we got some things that we have to do. So to create an equation for this, we have some important numbers. So the center is going to be hk. So the cool thing about conics is that the center is always going to be defined as hk. Okay, that stays consistent. But we're going to introduce some new variables here. So the new variables is going to be the distance from the center to the focus, and then the height of the minor and the width of the major. And remember, they can switch, right? So it's basically what's the distance from your center to the edge of your major, and what's the distance from your center to the edge of your minor. Okay, so to do this, the distance between the center and your focus, sorry about that, we call that C. The distance from the center to your major is A, and the distance from your center to your minor is called B. And I'll write these all out. So A is the distance from center to major vertice. Do they call them vertices? Oh, yeah, they do. So it's a singular vertex. B is the distance from the center to the minor vertex. And C is the distance from the center to the focus. Yeah, the foci will always be the same distance from the center. Yep. And there's a reason for that. So and that's a great question. So there's a reason for that because remember that each point on the circle is going to be a sum of these two distances. So using this, right, if this height is b and this is c, then this distance right here is going to be the square root of b squared plus c squared, and this is going to be the square root of b squared plus c squared. Right? So if that definition holds true, then this should be an isosceles triangle. Okay, so they have to be the same distance from the center. Does that answer your question? So, and if you ever have that question again, like, do they have to be the same? You can always just kind of prove it to yourself and be like, well, then there has to be a point. If this is B and this is C, then this has to exist, which means it has to be, it's going to, right? These two triangles are the same triangle, right? So then if this is C, right, this would have to be C. Because there exists a point where the distance between F1 and F2 to a point on the ellipse has to be the same. And if that's true, then C and C have to be the same. All right, cool. Pretty neat. I mean, this is crazy, guys. Like, these are naturally occurring shapes, right? So a big thing, and I know I'm kind of talking and we're not doing stuff right now, but a big thing about this, you guys watch the Mars lander get on Mars? So a cool thing about ellipses, and this has nothing to do with what we're doing today, but I'm a physics person. So the cool thing about ellipses is that, and you're going to learn this in calculus, so the rate of change has to do with curves. It has to do with the curve. So if we drew a tangent here, right, it's pretty flat. But as I get here, do you see how my tangent increases? And what's happening is that things in orbits that do this, you're going to be traveling in speed, but what happens when you approach this curve, you actually speed up. So if you look at orbits, when orbits are towards their major axis, the vertice of their major axis, they start speeding up. And so if you want to slingshot something, let's say to Mars, what you do is you put it in an elliptical orbit around Earth. And then what it does is every time it goes around here, it gains momentum. Okay? And so and that's how you slingshot to planets, is that you speed up and then you sling off like that, and you get it's called an orbital assist. And obviously I don't have time to explain all the mechanics of it, but it's possible due to ellipse and due to this major axis on an ellipse. Okay, and if we ever went to Mars and wanted to come back, we'd have to do the same thing around Mars. We'd want to slingshot around Mars and shoot ourselves to Earth on an elliptical orbit. Okay, if we were on a circular orbit, then we would be maintaining the same speed all the time. Okay, pretty cool, right? Now, Earth's orbit around the sun is pretty circular. It's pretty close, and we'll talk about that today. We'll talk about eccentricity, which is how close to a circle is it. Okay. All right, so this is our basics. You're going to want to have this in your notes. It's basically just what everything's going to be in our formula. So A is the distance for your major axis. B is it's half the distance for your major. B is half the distance for your minor. And C is the distance between the center and the foci. Okay, great question, by the way. Gosh, I wish I could talk to you guys about physics all day. I can't. You guys, it's just too bad. All right. So what are we going to do with this? Okay, so we have equations that are given from this. So, and this is going to look awfully a lot like a circle, okay? So the standard, so we're going to have two types of ellipses. There's going to be ellipses that are big around the waist, and then there's going to be ellipses that are big up and down, okay? So let's write both of these down. So we're going to have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Okay, now this should make sense. Remember, a is major. So here, the major is with the x-axis, right? So the major axis is horizontal. Okay, and that means it's bulging at the waist. Waist, wrong waist. Okay, sorry, am I too zoomed in? There we go. Bulge at the waist. So again, this equation, notice how so this is how I remember, the major axis, right? The A is with the X, so it's bulging in the middle. So if I went like this, it's bulging out like a hamburger, right? A hamburger, if you look at the cross section, is an ellipse. Okay, so if you look at a hamburger like this, it's bulging out like that. So that would be this equation. So then if you have the same equation and you put the minor with the X, then this one is an ellipse where it's going up and down in our reference. So this is the major axis in the vertical. Okay, so you can think of that as tall and skinny. Okay. If I had to, right? So you have major, and the A tells you which one you're with. Okay, so that's what's going on there. Okay. So the foci lay on the major axes always. And they're C units from the center. Okay. And another good point to go back to that question with is it always going to be that they're the same C units on either side? If they're not the same C units from the other side, you're going to get a different type of conic. Wink, wink, wink. Okay. Now, because of this, it gives us a formula. And that is, and I don't know about you guys, but like this ruined me in high school because what's Pythagorean theorem? A squared plus B squared equals C squared. Well, the way that it's set up though, it's C squared equals A squared minus B squared. And I could never remember this from my life of me. So you guys have it really easy this year because you can just have it in your notes. Okay? So that's the formula that connects all of them. Now, if you want, right, all that it is this, right? Because that what's connecting them, right, with C squared A and B, right? It has to do with the triangles that are going on there, right? And the idea is that okay, I just don't have time to derive it for you, so you guys are just gonna have to bear with me on that. I think, is there a derivation? No, there isn't. Okay, I don't have time to do that because we have things to do. But this is the equation that sets them all together. It really is just right triangles. So yeah. Sorry that I'm not going to spend time doing that. Okay. All right. So use this. If you are missing one of them. Right? So if you have a problem where they're given C but you don't know B, then you can use this to solve. Or if you know the A and B but you don't know C, then you can use that. So that's how you're going to use that there. I really want to derive it. Okay, if we have time, I'm going to derive that for you. Oh, they do have it in the book. They do. They do have you. So what they do is they just set two distances equal to each other, and then they simplify it. So if I have time, I'll come back to it. It is in the book. We don't have time. Okay. So it's on page 709 if you guys want to, but it's just basically they just say, hey, they use the horizontal axis, and they just add up the two distances and say, hey, this will equal 2a, and then they go from there. Anyways, if you guys want to do that, we can do that at the end of class. All right. Some other things that you need to know, right? If a equals b, then you have a circle. Okay. So if a equals b, then a equals b equals r. Okay. So that's something that you should also know, right? So if your major and your minor axes are the same, then that's your radius. That's your r. Okay. All right. That's all I want to do. Okay. And just really quickly, I want to show you some pictures. Here's the proof, by the way, that I was talking about in the book. So they just set everything, right? They just, hey, this is sum of the distance at the two foci, also be 2a, right? And then they solve for a. That's all they're doing. Okay. But what I really wanted to show you was this down here. This is what I'm talking about. So if you got the cross section of a hamburger, right? So you can imagine this is a hamburger, and I'm going to go like this, and I'm going to eat it. Yum. Okay. So H and K are your center, right? A is your major, right? A is your major. B is your minor, right? And this is going to be 1. Okay. And the reason why it's, well, we don't need to get there. It's just because it's not R. And you can do that from this, but you don't need to know that. Oh my gosh. All right. I wish we had more time, guys. Ellipses. Well, we're going to take 2 days on this. Okay. So going with this, how the heck are we going to do this? What are we going to do? Well, I'm really zoomed in. That's what's going on. So what are we going to do here with ellipses? I'll show you. Okay, so let's say here's an example of what we're going to do. Just day 1, and then we'll do more stuff with ellipses. Because ellipses, again, really cool. It's how you send things to Mars. Is that, let's say you have foci of 0, 1, and 4, 1. And the major axis has length of 6. Now, if we were talking about planets, we'd be talking about parsecs or light years. Probably. Or you can talk about AUs. Okay. So what we're going to do is now we're going to write the equation. Okay. So given 2 foci, well, I hope that showing your house goes well. Show it, and hopefully they're impressed and give you lots of money. Take care. Foci, so we got 2 points, and the major axis has length 6, and we're going to write an equation for this. Okay, so there's a bunch of stuff that we need to do. We need to figure out what axis is the major axis, and then we need to figure out C, we need to figure out A, we need to figure out B, and then we need to write our equation. So the first thing that you might want to do is the foci are always on your major axes. So if I just quickly graph this, and I have 0, 1, and I have 4, 1, 2, 3, 4, 1, okay, and this is foci 2, and this is foci 1, then you can see that my foci are on a horizontal line, right? So my major axis is going to be like this. So this is going to be my major. Okay. Now, we also know that our 2 foci are going to be the same distance from our center. So if they're the same distance from our center, and this is at 0 and this is at 4, what's halfway between 4 and 0? That's going to be at 2. I didn't draw this very square, did I? So this is going to be my center. So then I know my center is going to be at 2, 1, which is halfway between the foci. The foci. Oh my gosh. Feel like craft is subpar today. Very tired. Okay. So the center is 2, 1. It's halfway between the foci. Okay. So what does that mean our C is? That means our C here is 2. Right? So our C is 2. So we know C is 2. Okay. We know that our major axis has a length of 6. So if it has a length of 6, what's half of 6? Half of 6 is 3. So that means that, right, I'm going to have 1, 2, 3. There's going to be a point here. And then 1, 2, 3. There's going to be a point here. So this is a vertex. And this is a vertex. Right? Because if my total length is 6, right? So if I go from here, 1, 2, 3, 4, 5, 6. Okay, so there's my major. And then I have to find my minor. Okay, so to find my minor, we're going to use that equation c squared equals a squared minus b squared. Okay, so I know c squared is 2. I know my a squared is 3. And I'm going to solve for b squared. So if I subtract this, I get 2 squared minus 3 squared equals negative b squared. What is this? 4 minus 9, negative 5. Divide by negative 5 equals b squared. So then I'm going to take the square root. So I'm going to get b equals plus or minus the square root of 5. Okay, now in this sense, we're defining b as being positive, so the negative doesn't make sense here. So we can go ahead and ignore that negative. Okay, so for us, we're going to say b equals square root of 5. Okay, so let's recap everything that I did here, right? I was given 2 foci and the length of the major. If you just quickly sketch where the 2 foci are, it's really easy to find the center, right? So again, we have h and k. Oops. Yeah, we have h and k. And then it's easy to find c because you just count the distance. A is going to be half the total length. B, right, we use this relationship right here. We use the c squared equals a squared minus b squared. And again, the derivation for that is in your book. I just felt like we're going to spend more time solving than doing the derivation. And I'm sorry about that. Okay, so the last thing I'm going to do is I'm going to write my equation. So in this case, the standard, right, is I'm bulging in the x, right? So if I'm bulging in the x, then my a is going to be with my x. Okay, so I'm going to go ahead and plug things in. So x minus h, can you guys, oops, sorry, can you see this? X minus h. So I'm going to have x minus 2, quantity squared. And then on the bottom, I'm going to have a squared. So 3 squared is 9. And then I'm going to have y minus 1, quantity squared. And then on the bottom, I'm going to have b squared. B squared is 5, so I'm going to have square root of 5, so 5, and then equals 1. Okay, so we want to be able to find our center. We want to be able to find C, A, and B. And if I did this, what's square root of 5? Square root of 5 is like a little bit more than 2. So I'd go up 1, 2. 3. So then right here, a little bit less. 1, 2, 3, so a little less. So if I had to sketch, it looked something like that. There's my sketch. Kind of cool, right? So this height right here is square root 5. This height right here is 3. Right, that's everything that's going on there. Oh man, guys, I'm low energy today. It's like, come on, Craft. Don't be such a downer. You guys doing okay? That was a lot, wasn't it? Was that a lot? I can't tell. You guys don't give me enough feedback. I teach Algebra 1 and then Geometry and then you guys, so I never know if I'm going too fast or too slow. You guys are doing okay? Okay. Well, we should try another one. Do you guys want to let's try one on your own. Let's try one on your own. Let's do this one. Okay. So, you're going to write the equation. So, write the conic equation given. So, let's say we have your foci are at -2, 2 and 4, 2. And your major axis has length 10. Okay. So we're going to write a conic equation. And I'm going to give you guys some time to do this. Let's do let's do 2 minutes. And let's see if you guys can do that. And I highly suggest drawing a picture. All right. Was that enough time, or do you guys want a little bit more time? More. All right. For the sake of time, I'm going to start going over this. Let's try it out. So I'm first going to plot this. Just give a sketch so I can have an understanding of what's going on. So I'm just going to draw my little coordinate system. Right? And then let's go -2, 1, 2, and then up 1, 2. So I'm going to have a point there. And then I have one at 1, 2, 3, 4, and up 2. So it looks like this is also going to be, because the foci have to be on an axis, it looks like this is going to be my major. So my major is left to right, because they have to be on one, right? And they're not up and down. So that's good to know. And then it says the length of my major is 10. Okay. So the first thing I'm going to do is I'm going to find the center. So what's in the middle of this? So the easy way is just to find the average of -2 and 4. So if you add them up and divide by 2, so that would be 1. So right here is my center. Okay, so I have my focus 1, I have my focus 2, and this is my center. Okay, so again, to find the center, you're just taking the average. I mean, so it's on the x-axis, right? If my major was up and down, then I'd take the average of my y's. Does that make sense? So to find your center, right, you're just finding the middle place. So it looks like my center is going to be at the point 2, 2. No, 1, 2. Dang it. I wanted 2, 2 to be a thing, and that's bad science right there. Okay, so it's 1, 2. Okay, and then we can find C. So what's C? C is going to be the distance. So if this is 1, I'm going over 1, 2, 3. Does that make sense? 1, 2, 3. Yeah, so C is going to be 3. Okay, so then if C is 3, it says my major length is 10. So I know A equals 10, right? That's given. Okay, so we're going to find B now. So I know C squared equals, oh my gosh, I think it's A squared minus, how did I write it? I threw it to the ground. All right, C squared equals A squared minus B squared. Okay. You can tell I have this super memorized. So I have C squared equals A squared minus B squared. So C squared is 3 squared. So then I have 10 squared. So that's 9 minus 100. So 9 minus 100 is -91. The negatives go away, right? Because I'm just going to divide by negative. So I get the square root of 91 plus or minus. What's the square root of 91? Who am I? Is it just the square root of 91? I think it is. Yeah. All right. So we can ignore the negatives. So we just get the square root of 91 equals B. And are we doing okay so far, guys? No one's really said anything. It's a quiet day. Probably because I'm low energy. When I'm low energy, students tend to be low energy. That's why it's bad for me to be low energy. So what do we got here? Square root of 91 equals B. So it's in the major. So then I know I'm going to have X minus H quantity squared. And I know that's going to be over my A because it's the major. And then Y minus K quantity squared. And that's going to be the minor. Okay, so the major is in the X direction. So to write my answer here, I'm going to have X, my center is 1, so minus 1, quantity squared. My major is 10, so that's 100. And then Y minus 2, quantity squared. My B is square root of 91, so this is 91, and that equals 1. Oh my God. Dang it. You know what? You're right. A is 5. Okay, so everything is wrong. Yep. Gavin, Lauren, like, you guys are on top of it. I made a mistake. I'm just not on top of my game today. So let's try this. So 5 squared is 25. So I'm going to get 9 equals 25 minus b squared. So then 9 minus 25. Gosh, I better use a calculator. I'm going to make more mistakes. Negative 16. So then I get square plus or minus square root of 16 equals b. Square root of 16 is 4. So this is 4 equals b. So let's try this again. So I'm going to have x minus 1 quantity squared. A is 5, so this is 25. And then y minus 2 quantity squared. B is 4, so that's 16. Okay, so thank you guys. I made a mistake. I'm off my game today. I'm not doing very well today. I apologize about that. That's our answer, right? So again, it says our total length is 10, so that means A is 5, right? So A is half that length, right? Just like because 4 here is my half my length for my minor. So if we go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then in the up direction we go 4. So 1, 2, 3, 4, 1, 2, 3, 4, right? So my ellipse would look something like this. Not a great drawn picture. Kind of like a blimp though. Okay. Sorry about that. So with that looks a lot better, doesn't it? Oh my gosh. Crap, making mistakes. Are you guys doing okay there? Sorry about the mistakes, guys. It's embarrassing. Okay. Do you guys want to do one more together? Okay. Let's do one more together. So maybe we can do this a little bit faster because we're running out of time. So we're going to write an equation. The foci, I'm just going to make some stuff up. So let's say I have negative 2, 4, and negative 2, negative 3. I should pick 2 even numbers. Sorry, I'm going to change this to negative 2. Or else it's going to be harder to do. Okay. And then let's say the major axis has a length of 12. So do you guys want to do this together or try on your own? What do you guys want to know? Yeah, totally on purpose. Oh my gosh. No, I'm gonna own up to it. I'm struggling a little bit today. So I think it's important for teachers to admit when they're struggling, because then when you're struggling, you know it's normal and that it's okay, that days happen and we fight through them and we get through the day. I think that's important. So what do you guys want to do? Do you want to do this together or try on your own? Judging from no comments, I think people are trying this on their own. Whew. So we're going to go one more minute on this at 12:07. I'm going to go over it. All right, I'm going to go over this. So the first thing I would do is I would plot the two foci. So they both look like they're to the left two. One is up 1, 2, 3, 4. And the other one is down 1, 2. So what's really important here is now the major is going up and down. Okay, so this one's a little bit different, right? With the major going up and down. The center is going to be halfway between these two. So again, to find the average or the middle, you're going to just add them up and divide by 2. So 4 plus -2 is 2, divided by 2 is 1. So that means my center is right here. So let's get this down. My center is going to be at -2, 1. Right, so this is my H and that's my K. And then I'm not going to make this mistake again. So my major total length is 12. So then my A is 6, right? That's half of 12, right? See, even I can grow, guys. I'm growing right before you. Just not my hair. My hair is decaying right before you, right? If you just need proof, there's no hair up there. And then, not that you needed proof. And then what's my C? My C is 1, 2, 3. And then we're going to find B. So to find B, we're going to do C squared equals A squared minus B squared. And I'm sorry that I did all these ones with major. I could have changed that to a minor. Right, you can be given either information. And then, so I'm going to have 3 squared equals 6 squared minus B squared. So what is that? That's 3 squared is 9. 6 times 6 is 36. Minus 36. And I'm really scared of getting this wrong, so I'm going to use a calculator because you guys, I don't like making mistakes. So a funny quote in college was, I take math seriously, and that's why I'm using Mathematica to do this two-step equation. If you guys know what Mathematica is, it's a programming thing. All right, maybe that wasn't as funny as I thought it was going to be. I'm tired. 27 equals B squared. I'm going to square root both sides, so plus or minus, but we don't care about the minus, so we're just going to get square root of 27 equals B. And then we can write our equation. So in this time, since my major is with my Y, when I go to write X and then minus my H, so the B is going to be here, so this is going to be 27, and then my Y minus 1, oops, quantity squared. That's going to be with my A. So 6 squared is 6 times 6 is 36. And that equals 1. So just some notes here, right? This is my B squared. This is my A squared, right? Because my major is in the Y direction. Okay. Now that takes us to 12:10. But if you guys have questions, I would love for you to ask them. I'd love to be able to help you out. Your homework is due next Thursday. We're going to spend 2 days on ellipses. So your this first part is just writing equations of ellipses because it's kind of different. And then next class, we're going to look into graphing them and talking about Y ellipses. Okay?